Let's take a look at our fourth conic section, which is hyperbolas. So quick review, one of the things that you have to know is how we would cut through our cone to produce each of our conic sections. So let's go back and talk about that. So first of all, if I cut through the cone at an angle and I cut all the way down through the base, and I just chopped that piece of my cone off, what I would get is this parabola shape here. So if I cut through the cone down to the base, I get my parabola. That was the first conic section. If I cut through my cone parallel, that's not parallel, sorry. If I cut through my cone parallel to the base, well then I cut a new base, and we know that the base of a cone is a circle. So if I cut parallel through the cone, I get a circle. That was our second conic section, the bad circle. And then if I cut through the cone kind of at an angle, then it's not going to be a circle, it's going to be kind of elongated, or that is our oval shape, and that was the ellipse. That was our third conic section. And so then our fourth is based on actually two cones put together, so this is called a double napped cone. We have two cones, and I'm cutting all the way through both cones and down to the base. So really what I've created is a parabola here, and then a second parabola here, and we call this shape the hyperbola. So I have a parabola on this side, and I have a parabola on this side, or we're going to see examples where that can actually be flipped so that my parabolas are opening upward and downward. But similar to the parabolas that we already talked about, we have the focus point and directrix and everything just like we did for the parabolas. So we're going to find some of those characteristics with this. We're not going to use all of them. Our objective here is to be able to sketch graphs of hyperbolic conic sections and to relate parameter changes. So if h changes, if k changes, if a or b change, how does that affect my graph? So we'll begin. We're on the worksheet graphing hyperbolas. And so we're going to look at how this is the same and how this is different from the last conic section we looked at, ellipses. And the formula is going to be very similar, but there is one important difference, and that is that my squared terms, in everything that we've done so far, the squared terms have both been positive. Get my pen working here. So in a hyperbola, the squared terms have different signs. So in other words, one of my squared terms is going to be positive, and one of my squared terms is going to be negative. So I could have an x squared that's positive and a y squared that's negative in my equation, or I could have an x squared that's negative and a y squared that's positive. And we'll look at how to graph each one of those and how it changes the graph. Also, we still are going to have a and b. A is our horizontal distance, B is our vertical distance, HK will be the center. But when we find A and B and we plot those points and everything, we're not going to draw the ellipse like we did last time. We're going to use those points to create a box, and that box is going to be our guide to help us graph the hyperbola. So let's begin first of all with hyperbolas that open left and right. So I have a parabola opening this way, a parabola opening this way, and that's my left-right hyperbola. And the equation for this, let's talk about that. So this opens left and right. The equation is almost identical to the ellipse. The only difference is that the ellipse had plus right here. Everything else is exactly the same. So we still have HK as our center, and they will still change signs. We still have to have it equal to 1. We still have the A value always with our X, and the B value always with our Y, and everything works the same way. But because of that negative sign right there, it takes this shape that used to open inward towards one another, and flips it to where it's now opening outward away from one another. So I still have this center point, HK, and my vertices will be, in this case, they're going to be right on the graph. So when we looked at ellipses, the vertices were along the major axis, so it depended on whether it was longer horizontally or vertically. With the hyperbola, the vertices are always going to be where the graph is. So I wouldn't want to put a point up here and say, well, that's a vertex, because there's actually no graph there. So this is just like the vertex of a parabola. And so the vertices are going to change, and they're changing, in this case, horizontally. So it's going to be my h value changing. So h plus my c. I'm sorry, I'm thinking ellipses. H plus my a value, and h minus my a value. I'm actually thinking focus points instead. And then we're going to talk about covertices when we actually do our problems. We're not really going to work with them very much. But just to recognize that these points are also important because they help us build this box. And we can't really call them vertices because there's no graph there, so we're going to call them covertices. And in this case, it's my k changing, and so it's moving up b units and moving down b units. And I'm also going to show you how to locate these using your calculator. The asymptotes, so we talked about asymptotes, rational functions and with exponential and with logarithmic. In this case, I have two asymptotes. And so remember, the big thing about an asymptote is that my graph will never cross it and never quite touch it. So these are just linear functions. They're two lines that kind of separate this out. So I have an equation. It's kind of an mx plus b form here. And for this, we are going to be using our calculators to find this characteristic. But the equation for this, it's going to be b over a. And then my linear function, x minus h plus k. And so this is like slope. So I've got the rise, or the change vertically, over the change horizontally. So the rise over the run. And then what I want to add right here is, because I have one that's increasing and one that's decreasing, we're going to have a positive version of this, and we're going to have a negative version of this. And we'll see that when we get into our characteristics there. Okay, the only difference between that graph and this one that now opens up and down instead of left and right is that it's not my y squared term here that's negative, as it was on the last one. Now it's the x squared term. So if my x squared term is negative, my y squared term is positive, my graph will open up and down instead. My center will stay exactly the same, hk. My vertices now are going to be here. So from my center, it's my k value that will change here. So my vertices will be at h, and then k is going to move up the units or down the units. And again, we will be using analyzing the graph to find a lot of these things. The covertices are here. So we have covertices. Now that one's moving horizontally. H plus a. I do this every time because I just wrote that e up there. It's okay. And h minus a. Okay. The asymptote formula is the same. So I've got a positive and a negative version. B over a, x minus h plus k. Alright, so you have to kind of figure out a way to help yourself remember that a negative x squared term means your graph is opening upwards and downwards, and a negative y squared term means opening left and right. So I'm a visual person, and so what I do to help myself remember that is I look at this graph, and so I use this one to help me remember both. And I picture that this is a set of gates right here. And so we have a set of gates and a handle on gates. And somebody has opened the gates and left them open. So that's what I just pretend this is. And so then I ask the question, why did you leave the gates open? Probably because I'm a mom, and moms are always asking their kids why they left things open or didn't put things away. And so that's just something I can associate together. So just think of something that with these pictures will help you, because then I remember y means that my y squared term is the one that's negative here, and that's the left and right one because they look like doors that have been left open there. So just try to find something that helps you remember. Alright, so let's begin looking at how to write an equation and how to graph these, just like we've done with each of our conic sections. So you have to know how to write an equation given a graph, and we're going to use our calculator some to help us here to find some of these parts, but we have to be able to write an equation first. So we're going to begin with, this is our center, it's where the asymptotes meet, it's the middle of everything, and that is going to be my hk value. So this particular one is at 0, 0. So this is h, and this is k, just like it always is. And I can figure out what A is by going from my center out to the point here. And so A is 2, and B is going to be from the center to the top or to the bottom, and so B is 3. And so start with vertices. So vertices are going to be where the graph is. So in this case, there are these points right here. And so I can write down the coordinates. It's at 2, 0, and at negative 2, 0. And then the co-vertices are going to be where you don't actually have a graph, but they are important points still, so I want to recognize them. And that is going to be at 0, 3, and 0, negative 3. Okay, the asymptotes, we're going to use our calculators to find. So when I look at the asymptotes, I'm trying to find the equation of this line and the equation of this line. But before I can graph it, I need to write an equation. So let's begin with x minus h. We're just using that formula. So x minus h, and h was 0 squared, over a squared. Now, normally we would go ahead and put a plus there, but I'm going to wait on that. Y minus k, so y minus 0 squared, over b squared should be equal to 1. Okay, then I have to decide, if it's a hyperbola, I have to decide, is it my y that's negative or my x that's negative? So again, this is my gates that have been left open, so it is my y value that's negative here, and my x value will be positive. So we're going to go to our calculators and graph this. So I want you to check, first of all, the conics graphing is only available on the newest operating system of the TI Inspire. So on the calculator you're using, first of all, if you'll go to your home page and check your settings, and go to your status, it needs to say version 3.21. Otherwise, you do not have the updated operating system, and you won't be able to graph your conic. So make sure you check that, and if you don't have that operating system, check with your teacher to get that. So I'm going to go and clear out anything that's in there, and we're going to go to the graphing page. And for all of my conics, I have to change the way I enter. I have to edit the way I enter my functions. So this is all set to where you're entering a function. I'm actually going to enter an equation with a special template, and so I have my hyperbolas right here. And I have two options, okay? One option has this is exactly what we were just looking at, a negative y value here. When the x value is negative, they switch this, and there's actually an error in this template because we've said all along that A should always go with your X terms and B should go with your Y terms. And so TI has made an error in the way they wrote this out, but don't follow that. Continue to put B under your Y term and A under your X term. But they have switched everything, so be watchful of this, that you're putting things in the right places, that you have your H with your K and everything the way it should be. For this particular one, we're going to use this template. So we're just going to enter, so this should be X minus 0 over 2 squared, Y minus 0 over 3 squared, and enter. And I hit the wrong thing. Hang on. Go back up there. I put 33, and that would be very large. We don't want that. So 3 squared, that's better. Alright, that's what we want to see. So this looks like the graph we were just looking at, and so we see that right here, these points we had marked as vertices, they look exactly the same. And so let's go ahead and check our vertices using the calculator also, and find the asymptotes. So I'm going to go to Menu, and just like we analyze any other graph, we can analyze this graph, but we have to come way down here and say Analyze Conics, and then we have all these options here. So we're going to start with vertices, and so before it will show up, you have to come and touch your graph. So here are the vertices that I wrote down, negative 2, 0, and 2, 0. That's the same thing that we had written right here. Now, the calculator will not find your co-vertices because they're not on the graph, and it can't analyze something that is not on the graph. So those are not a characteristic you can locate on your graph. But we can find the asymptotes because the calculator has used that to help guide its graph here. So we can go again, Menu, Analyze Graph, Analyze Conics, and we can go right here to asymptotes. And again, you have to come to your graph before they'll show up. And then you may need to pull these out where you can see them better. So I'm going here, see if I can get this one pulled up. So here are my two asymptotes. One is increasing. Now they won't always look exactly the same like this. This is only the case when your center was at 0, 0. So I've got 3/2 x and negative 3/2 x, and those are those lines right here, the asymptotes that separate my graph. So we have one at 3/2 x and one at negative 3/2 x. Right, I want to talk really quickly then how you would see this. Now I wrote this way specifically so I could put it in the calculator easily. But if you were looking at just an equation somewhere, it would be written like this instead, just like with our ellipses. So I have squared my terms and I've left my h and k off. Okay, so let's look at one then that doesn't open left and right. This one opens up and down. And my center in this one is right here. So my coordinates are 3, negative 2 for my h and my k. And my a value here is just 1. And my b value is 3. And so for this graph, my vertices are going to be these points because they are on the graph. And so I have a vertex at 3, 1, and I have a vertex at 3, negative 5. The co-vertices would be these other points that I used. So I've got 2, negative 2, and 4, negative 2. And I need an equation so I can graph this. So let's start with x minus h, so x minus 3 squared over a squared, y minus k squared over b squared equals 1. And then I have to decide, okay, do I need a negative sign here, or should that be positive? Do I need a negative sign here, or should that be positive? Well, this is not my gates opening here. And so this one is my negative that's in front of the X instead, and my Y will actually be positive. And so here's how you would see that written then. I'm going to simplify a couple things here, because I wrote that out specifically in a form that would work with the calculator. Okay, so here's one thing we would also leave off. If a whole number is over 1, we generally don't write that down. So this 1 squared is just 1. So you would see that part written just like that. And then minus a negative 2 becomes plus 2. And over 9 equal to 1. So this is a form that I would have to use for the calculator, but this is how this would actually be written. So let's go find our asymptote. We need a new graph. And again, I have to go through this process every time. I'm going to edit the way I enter this. It's an equation. It is a hyperbola, and I need a negative x squared term. So I'm using this form. So let's go ahead and do our x first. So this was x minus 3 squared over 1 squared. And then we'll do our y part here next. And so notice they're in the opposite order as what we had them written out here. So we want minus a negative 2. And since there's a minus already in our template, we have to put that negative 2 and 3 squared. And there is my hyperbola. And we're going to go menu, analyze graph, analyze conics. I can check my vertices. There are my vertices. I can find my asymptotes. Those equations up. So you'll see that these equations are not similar, well, a little, but not just a positive and a negative version of the same like the last. 3x minus 11 and a negative 3x plus 7 are my asymptotes here. Okay? Then let's look at how to graph a hyperbola based on its equation. So I'm going to start with the center. So here is my h, here is my k, remembering that they always change signs. So it's going to be positive 3 and negative 1. So I'm going to plot my center point at 3, negative 1. My a value is always found under my x term, and it will be the square root of 16, and the square root of 16 is 4. So that means from my center, I'm going to go to the right 4 units and make a point there, and I'm going to go to the left 4 units and make a point there. So I have a point at negative 1, and I have a point at 7, negative 1. And I don't know for sure yet whether these are my vertices or not because I haven't drawn my graph. My b value will be under my y term as the square root of 9, which is 3. And so from my center, I'm going to go up 3 and down 3. So at 3, 2, I have a point. They've actually told us that these are our co-vertices and these are our vertices. And at 3, negative 4, I have a point. Okay, so we're going to draw a box rather than an ellipse here because I had a negative squared term. Happened to be my y this time. Create this box using those points. And I'm going to go ahead and draw my asymptotes. So my asymptotes are going to go through the center and out. It's kind of like a diagonal through my box here. and then from here, out this way, out this way. So I have these asymptotes, and so I've got my guide for my graph. So then all I really need to do is decide, does my graph go left and right, or does my graph go up and down? And so I can look at which term is negative for that, and so it's my y term, so I always ask myself, yeah, so why did you leave those gates open? And there are my, I'm going to go ahead and draw them then. So I have a parabola opening to the right, and a parabola opening to the left. And my parabolas will not cross over my asymptotes, they're going to stay within that area, kind of confined right there. Okay, go ahead and pause here and complete the graphing hyperbolas page, and then we're going to look at completing a square for hyperbolas. Alright, for this problem, I gave an equation that is not really in a nice, neat form, just because I want to make sure that we understand that everything has to be moved before we start completing the square and getting things into their standard form. So what I'm trying to do, here's my goal, is right now I have this general form, everything's just straight across numbers, and we can graph in, not exactly in this form, but we can graph in general form, but I'm trying to get to this form here. And I'm going to use plus or minus because we don't know for sure. Whether it's the x or the y that's minus in a lot of our cases. But we're trying to get it into this standard form here from this. And so step one has been, every time we did this, that we need to move all of our variable terms to the left, and anything that's just a constant is going to be on the right. And we're going to organize and group things together. So right now I have this, I have two terms with variables on them in the left, but on the right I've got variable, constant. Okay, so this is exactly where it should be. The constant term should be on the right. But these two terms, they need to go over to the other side. And so let's move them over. And when I take something across the equal sign, kind of skipping some steps here, but basically its sign is going to change. So that is going to become a positive 4x squared and a positive 72x. And then these terms were where they needed to be, so I'm not moving them, which means they're not changing signs. And this was where it needed to be, so I'm not changing that sign. So I only change a sign if I pick it up and take it across to the other side of the equation. Okay, so as I did that, I went ahead and grouped my x terms together and my y terms together. Alright, so then let's begin the process of completing the square. So first of all, it'll make things much simpler for me if I go ahead and factor out my a value here. So I'm going to pull that 4 out here. So I've got x squared, because that means that's my greatest common factor. Then I'm going to divide each of my x terms by 4. So 4 divided by 4 gives me 1x squared. Plus 4 goes into 72 18 times. And I'm going to go ahead and make room here for my b over 2 squared. It's that same thing that we're doing all through this. Right, my a value here is not 1, it's a negative 1. So I need to do the same thing here, even though there's not some larger number. So I'm going to factor out a negative 1, which means I'm dividing this by negative 1 and this by negative 1. So that changes this to a positive y squared plus 10y and plus b over 2 squared. And then let's go ahead and make that space on this side too. So I have a negative 199. Right, and then remember here that I did not just add b over 2 squared. I actually have to multiply that by 4 also. So we're going to go 4 times my b over 2 squared here. And then I had a negative 1 times my b over 2 squared here. So I'm actually going to be subtracting that second term. And then let's go ahead and find our b over 2 squared for this one. So here's my b value, so it's going to be 18 over 2 squared, which is 9 squared, or I'm adding 4 times 81 to both sides. Here my b is 10, so 10 over 2 squared, 5 squared. So I'm adding a negative 1 times 25 to both sides. And then we're going to factor. Let's start with our x terms here. So I've got a times c is 81, c is 18, so square root of 81 is 9. 9 times 9, and since I want a positive 18, they're positive. So I've got x plus 9 twice, minus 1, and then let's factor here. So a times c is 25. And just remember, this is a in front here, this is b, this is c, and my b here. And the square root of 25 is 5. So I know that 5 times 5 will give me 25. And I want a positive 10, so I'm using y plus 5 twice. And then let's simplify on the right. So I'm going to go to the calculator for that. And we need a calculator page. And I have negative 199 plus 4 times 81 minus 1 times 25. So that's equal to 100. And it has to be equal to 1 to be in standard form. So my final step is I'm going to divide everything by 100. And then let's go ahead and reduce or simplify anything we can. So I can simplify 4 over 100 becomes 1 over 25. So I've got x plus 9 squared over 25 here. Minus, now this one, 1 over 100 is not going to simplify at all, but I don't have to keep writing that 1 there. Equal to 100 divided by 100, which is 1. So I have my standard form here, which means that the center, I can now locate my center, and my center will be at negative 9, negative 5. And I can also see that my a value is the square root of 25 of 5. My b value is the square root of 100 or 10. And that this is going to open left and right because it's my y that's negative here. Let's work one more example together. Same situation here. My terms are not where they need to be. My y terms are on the left, they're okay. My constant needs to move, so this is moving, and this is moving. So if it's moving, its sign is changing. If it's not moving, its sign is not changing. So I'm going to take my negative x squared over here. So I have x squared. I'm going to take this positive 18x over here. So I've got minus 18x this stays, this stays, this is moving to the other side, so it's equal to 19. Alright, then let's begin completing the square. Now, this one has an a value of 1, so I don't need to factor anything out here. A little less work. I'll go ahead and leave space for my b over 2 squared here. This has a negative 1, so I have to factor out that negative 1. Fy squared minus 12y, and my b over 2 here, is equal to 19 plus my first term minus my second term. Okay, so b over 2, I have a negative 18 over 2 squared, so 9, negative 9 squared. Make sure you keep that in parentheses, otherwise your calculator is going to try to tell you that this should be a negative value, and it shouldn't. We're adding 81 to both sides. Negative 12 over 2 squared is negative 6 squared, or 36 to both sides here. Alright, so factoring, my a times c is 81. My b is a negative 18. So I can use 9 and 9, but I need a negative 18, so I'm going to have to use negative values here. So I've got x minus 9 twice. Minus 1, and we'll factor here. A times c is 36. B is negative 12. So in the same way, I can use 6 and 6 here, but I have to use the negatives because I need a negative 12. So I have y minus 6 twice. Equals, and so let's go ahead and simplify here. 19 plus 81 and I get 64. So that is equal to 64. Alright, I need it set equal to 1, so let's just divide all the way across. And there really isn't anything to simplify here, so my final equation will be x minus 9 squared over 64 minus y minus 6 squared over 64 equal to 1, with a center of 9, 6. And my a and b values would both be the square root of 64 or 8. So I want to point out here that when we were talking about ellipses, if a and b turned out to be the same thing, then it was actually a circle. But in this case, it doesn't matter if a and b turn out to be the same thing. This negative squared term right here means this is still a hyperbola. It's just that that box that we would have to create in the middle will be a square because it's the same distance here as it is here. Okay, so between this and what we looked at in finding or analyzing the graph on the calculator, you should be able to complete your worksheet on hyperbolas also.